Hey everybody, we're going to move on into chapter 8. Now, I made up this section. There's really not an 8-10 in the book, but I didn't like that the book expected us to teach how to add and subtract polynomials and all that stuff, but not really like teach it as its own lesson. So that's why there's this whole extra lesson here. Okay, so I just didn't think it was fair to try to teach you too much at once. So I'm going to teach you how to find what I would call a remaining area. So we're going to get two boxes. One's going to be inside the other one, like a rectangle, and we're going to remove a rectangle and find the remaining shaded area. So number one, I made pretty easy. I have the 3 steps here and how to do it. I'll walk you through them. So we need to find out if we have this overarching rectangle and we take out like a chunk of it, maybe for a window or whatever it might be, what is the remaining area here? Now, this one is pure numbers, so it's not going to be quite as hard as the rest of the stuff we'll go through. But let's go ahead and I'll show you with an easy problem the steps. So the first thing you need to do is find the area of the big rectangle. So that would be length times width, which of the big rectangle is 10 meters and 12 meters. So I'm going to do 10 meters times 12 meters is 120 square meters. Don't let the square meters, don't let that bother you so much. As long as you get 120, you're probably sitting where you need to be. Now what we need to do is find the little one removed. So the little one is a 2 by 7. So the area of the small one is 2 meters times 7 meters, which is 14 square meters. So to find what's left, if we're to have 120 to start with, and we're taking away the small one of 14, you take the big one, 120, you subtract the small one, which is 14, and there's nothing really to distribute here except for the tiny little negative sign. So it's 120 minus 14, which is 106, and that's going to be square meters, whatever units they have, in this case meters. So that's the process. Now what we're going to do is, instead of just doing this with like constants and numbers, we're going to do this with polynomials. Okay, so let's move into number 2. Again, you can see number 2 got a little more difficult. So the steps are the same. We need to take the length and the width of the big rectangle and find the big area, like before we remove the little white chunk there. So let's see, my length and width, 13x and 6x. So we got to do 13x times 6x. And let's get that calculator pulled up so you can see the keystrokes that you'll have to press. So I'm going to do, where's it at? 13 times 6. So I have 78. And then x times x is x squared. Now, whatever this would be in square units. So I'll just kind of write that to the side. Now it's time for us to find the small area. And I did not write, I just wrote 7. I didn't write 78. So that's the large rectangle. So the expression is 78. So now the small one is a 2x and a 2x. It's actually a square. So we're going to do 2x times 2x. This is the small rectangle. So 2 times 2 is 4, and x times x is x squared. Now remember, this is square units. Not a huge deal. I just want you to know your units. And now to find like what's left. So what's that area shaded? Like after we have the big one and we take away this little guy, like what's left? We take the big area, which was 78x squared, and we subtract the small area of 4x squared. There's really just one distribute here, and we just have to do a minus 4x squared. And now we ask ourselves, are these like terms? Well, we've learned that like terms have the same variable and the same exponent. So these are like terms. So 78 take away 4 is 74, and then you keep the x squared as x squared. Since we're still talking about units, it would be unit squared, whether it's inches or meters or feet or whatever. So I'm just going to throw that to the side. All right, we're going to do that again, but it's going to get harder as we move along. Now I want to highlight the final answer. So this is the expression that represents the remaining area of the shaded area. All right, so number 3 is more like a brick wall, and it looks like maybe we have like an elongated window. So the big rectangle, the outside rectangle, is 3x take away 1 and 3x add 7. So I need to find that area. So I have 3x, notice I'm writing smaller here, 3x take away 1, it's a binomial, and I do believe it was 3x add 7 was my other one. I need to double check. That's correct. Now, to distribute binomials, we have a lot more to deal with here. So we have that's going to make 9x squared. That makes add 21 with an x. We've done this in previous sections. That's take away 3x, and that's take away 7. So now we do combine our like terms here in the middle. Those are like terms. So we have 9x squared and 21 take away 3. Whoops, 21 take away 3 is 18. I just wanted to show you, just in case. That's my dog. And she's barking. So it's a positive 18x and then a take away 7. Now this is just of the big rectangle. So this would be square units if you're wondering about your units. Now we have to find this area of the small rectangle. So let's go over here. And this one, again, it's going to be a little more difficult than the previous problem, okay? I stepped it up on purpose. So length times width is x times 2x plus 5. Now remember, you can write this one of two ways. You can do x and then 2x. What was it? Add or minus 5, sorry. Add 5. So you can multiply like that, the length and the width. Or if you want, if anybody really wants, you can put the x back here. However, it's weird to me to backwards distribute. It's just not something we typically do. So I'm going to put it in the front. So we have to do this arc, which is going to be 2x squared when you multiply, and this distribution, which is going to be 5x. Again, this is area, so it would be square units. Now, just like the previous problems, we're going to subtract the big one from the small one. So in fact, here, I'll just duplicate it so you can see that. So we're going to do this one, and then we're going to do a takeaway sign. I'll do that in a thicker black pen. And now I want you to very carefully watch how I'm going to put the area of the small one in parentheses. Now these steps, I hope you enjoy the steps. Like I feel like I took a long time to write them out properly. They will not be provided on the Keystone, so you'll notice as we progress through the lesson, I drop them off. So the first polynomial, you don't distribute anything into that. You just bring it down. So I duplicated it. And now we're going to have to take our time here because we have to subtract the 2x squared and we have to subtract the second term. So that's going to be a minus 2x squared when I distribute a negative and a minus 5x when I distribute a negative. And at last, it is now time to combine like terms. So I see 9x squared minus 2x squared. Well, 9 minus 2 is 7 with an x squared. I see plus 18x and minus 5x. That is plus 13x. And then I see minus 7 as just kind of its little lonesome back here. And this is area, so it's in square units. So my final answer, my expression, my polynomial that represents that leftover part there that after we took it out would be 7x squared plus 13x take away 7, and then whatever my units, whether they're feet or inches, would be squared. Okay, I apologize. I did not realize that these steps did not transfer over well on the PDF, so I apologize. This should have been 1, 2, and 3 for the new problem. I'll have to try to fix that before you get there. So let's take a look at the fourth example, okay? So the fourth example, again, this is the most difficult example there is. So I have 4 on here, and it's not taking me too long. Oh, and look, I have a whole bunch of extra that I might want to save for the future. This is the hardest one. So I had to do these 2 because those are the big rectangle. I had to find that area. So I'm going to go over here, and I'm going to write area of big. Notice I left off the steps, because I have to be able to do this by myself on the Keystones. I'm not going to have these guiding steps. So 2x plus 4 and 3x plus 6. 2x plus 4, notice a binomial goes in parentheses. 3x plus 6. So we have 3x plus 6. Now I gotta like multiply that through, okay? So I'm going to do 2x times 3x is 6x squared. 2x times 6 is 12x. 4 times 3x is 12x. And 4 times 6 is 24. Everything's positive. It made our life really easy. Now we have to combine these. So we have 6x squared, and 12 and 12 makes a 24, and then the extra 24 in the end. Please remember, this is the area of the big rectangle, okay? Like that, the overarching rectangle. Now we're going to remove that inside rectangle. I'll just make it brown, whatever. So you see this small rectangle? The area is the length times the width, and we've done that in a previous lesson. So I'm going to write area of small. Now remember, it's length times width, right? So in this case, my length and my width are 3x minus 1. Does not matter which one you write first, as long as you're careful with your distributing. And 2x minus 1. And that is because multiplication is commutative. Like you can like switch watch your multiplication. And now it's time to like work this out so I'd actually get an area as a polynomial. So that's going to be 6x squared. That's interesting. That's going to be take away 3x That's going to be take away 2x, and that's going to be add 1. I have to combine my like terms because I actually have some. I won't always have like terms here, but in this case I did. Again, I don't always have like terms, but in this case I did. Like they had two x terms, so I had to put those together. And now to find the remaining area, so I'll just change this to area, and I'll write the word remaining. You have to take the big one. And you have to subtract the small one. So I'm going to get this tool here. Now I want you to watch very carefully what I do when I subtract it. I draw a minus sign and parentheses so that I remember to distribute my negative. Because if you don't distribute your negative, you're simply wrong. And because it's such a common mistake, like kids will just write this and they don't like apply the negative anywhere. Sorry. A lot of kids won't distribute the negative like they should, like a really large amount. That answer will probably be on the keystone. So you have to be very careful with that. So let me draw my parentheses back on. Now what I'm going to do is, thank goodness we have this app where I can just shrink things down. I am going to just shrink all of this down. That way I have more room to work my algebra through here. Okay, here we go. So this was part 1 above this squiggle. Here's part 2 above this squiggle. And now it's time to finish. So as we have done with subtracting problems in the past, this comes down. As we have done with subtracting problems in the past, we distribute our negative. So it's minus 6x squared. Now it's adding 5x and take away 1. And now, as we've done in the past, we have to simplify, right? So we need to look for some like terms. Let me minimize the size of this pen. And I see this x squared, take away this. So 6 minus 6 is 0x squared. And I will get rid of that. Just follow along with me. Plus 24x and plus 5x is plus 29x. Notice we do not change the exponents when we combine our like terms. Positive 24 and negative 1 is positive 23. So my final answer, remember this is area, so this would be in squared units or units squared. We don't say units squared, we say square units. My final answer will be, I'm going to get rid of anything that doesn't matter, right? Like that 0, I don't write 0. It's not like I went to the store and I bought 3 plus 0 eggs. I wrote 3, you know. My final answer for the remaining is 29x plus 23. So as a review of our steps, you will always find the area of the largest rectangle, the outer rectangle. You will find the area of the little rectangle that's being removed. And then you have to subtract that little rectangle from the big one. Remember, you have to distribute a negative when you subtract. And let's just add an extra step here that maybe we sometimes forget. Make sure at the end that you combine your like terms. All right. And remember your units will be squared or square units. All right. Wasn't too hard. I mean, you know what? That could be very hard, but I tell you what, it didn't take too long to explain. Now let's see how you kind of like put it all together yourself.